Tides. Tides also has to do with the moon. Now, this is another one, reference table, a great document, not going to help you with tides at all. It's got to be up here, so pay attention. So this is how tides work. What I have here is I drew in Earth, and the sun is over there. This is looking down at Earth's North Pole, and let's say the moon is there. Now the moon has gravitational pull on Earth's oceans, so it pulls the water on Earth towards it. And what you get is a bulge that looks like this. So you have a bulge here. Oddly, I'm not going to explain it now. They have a bulge here, and you have sort of, it's thinner here. The oceans are thinner here and thinner here. Now, this is way out of scale. This is only a few feet difference, really. So what that means is, if you are this person right here, you are experiencing a high tide. You're in this higher bulge. And let's say, pretty much for one day, the moon kind of stays basically in one place for a day. It moves a little bit, but let's just assume for this it doesn't. So you're here. Let's say this is at noon, okay? As time goes on, this is afternoon, 1 p.m., 2 p.m., 3 p.m., 4 p.m., 5 p.m., 6 p.m. It's low tide, okay? So during this time, you're seeing the tide going out, 6 p.m., and now it's low tide. And then as you're here, as you're rotating, it looks like, oh, the tide is coming in, the tide is coming in, the tide is coming in. So like 12 hours later, now this is midnight, 12 hours after you started, you experience a high tide again. And then the tide looks to be going out, Now it's 6 a.m. the next day, and then 6 hours later, you're back here experiencing a high tide again. So that's kind of how it works. I really like to show that to demonstrate that. So you get 2 high tides and 2 low tides every day. Okay. Now this is sometimes how it's drawn. I don't like this as much because it's not in color, and has the low tide and high tide here. This bulge. It has the moon. It has the sun. You often see it that way. So that's just an example. Now, what I want to point, so this is about gravitational force on the oceans on Earth. And both the moon and the sun affect Earth's oceans. The moon has more of an effect on the tides than the sun does, and that's because the moon is closer to Earth. Even though the sun is way bigger, has way more mass, it is 400 times further away than the moon. So the moon has more gravitational force on Earth's oceans, so that has more of an effect. But the sun does. So we're going to see what if they work together, or sort of when they work together, what we get. So in this case, again, totally not to scale. Look how small the sun is. Holy cow! Look how big the moon and Earth are the same size here. So crazy. But basically, what I tried to draw here is when you have this case, the sun's gravitational force is pulling the water this way, and the moon is pulling this way. Now, I want to say they're working against each other, but they're not. They're working at right angles. One's pulling like this way, the other one's pulling that way. So what happens here is you get the high tides aren't as high and the low tides aren't as low. But when you have a situation like this, when they're in the line, and now the sun gravity is pulling the water that way, and the moon is pulling it that way, so they sort of work together, and their gravitational force builds up and adds to each other. Therefore, you have higher high tides here and here, and you have lower low tides here and here. Okay, that is important. So what I wrote is in this scenario here, if the moon is here, or the moon is even here, that happens, as well, you have less dramatic tides, which means high tides are not as high, low tides not as low. But when you have the moon here, or the moon can also be here, you get more dramatic tides, and what I mean by that is you have higher high tides and lower low tides. Okay, that's important to know. Hey, Mr. Gazda here. I hope you're liking this review so far. For more review videos, click the link in the description. Now, a lot of the questions on the Regents exam that we see will have tides and will have charts. A lot of times this is just about reading the chart, predicting when the next high tide will be. So it's not so much based on the information that we just went over. It's more, can you read the chart and then predict based on the time when the next one is. So I do want to point, just for instance, on this day, you do see the 2 low tides in the day are here and here, and the 2 high tides are here and here. Now, there's a little bit of a difference there, but that happens. So that's important. You often see these So be ready for it. For instance, here's another one, Long Island tides, and it kind of shows you over, and you got to like read the scale, what day. This is July 12th, this is July 13th, and when's midnight. So it's really reading, these ones are really about reading a chart, reading a graph, and doing some predictions, more so than understanding the concepts of tides. That's just how it goes.